Hi folks, today we're going to talk about adding and subtracting rational expressions. Remember the root word of rational is ratio, which is fraction, so we're going to remind you about what you used to know about adding and subtracting fractions. So let's say you're trying to add fraction 1/6 and fraction 1/2. Well, hopefully you remember that you can't add these fractions until they have common denominators. And so what you need to do is figure out how to make common denominators and what that denominator should be. So 2 can't be broken down anymore, but a 6 can be broken into a 2 and a 3. So I noticed that they both have 2's, but this one has a 3 and this one doesn't. So in order to make common denominators, I'm going to multiply both the numerator and denominator by the 3. So now this becomes 1/6 plus 1 times 3 is 3. 2 times 3 is 6. So 3/6. Now they have common denominators. 1/6 plus 3/6 equals 4/6. And of course I can simplify that later, but that's not the point of what we're doing today. The point of what we're doing today is trying to get those common denominators in our rational expressions with variables so that we can do the addition and subtraction that's required of us. So you must have a common denominator. Now we're going to be talking about the LCD of the following rational expressions. LCD stands for least common denominator. So for a 6 and a 2, the least common denominator is 6. They could both be turned into a 6. Now any common denominator would work, but the least common denominator is what we were looking for. For example, both 6 and 2 can have a common denominator of 600 because this can be multiplied by 100 and this can be multiplied by 300, but we don't want that. We don't want these crazy big denominators. We just want the least common denominator, the smallest term that we can get the denominator to be so that the denominators are the same. So the first rational expression I have, if I were going to combine these two rational expressions, first I'd want to factor or split apart. Remember, to factor means to split or break apart the rational expression. So in the first ratio, we have a 1 on top, we have a 5 on bottom, and an x squared, so 5 times x times x. Notice how I just kind of broke that all apart. Now when we think of factoring, we usually don't think about doing this, but I am breaking it apart into its tiniest pieces. Now the other ratio, into 2 and 2, those I can't break up. 10x I can break up. Factors. So the things that both of these fractions have in common. And they both have an x. Factor. The first fraction. Second fraction. And so what you get when you multiply these two together. It's what you want your denominator to be. So 5 times 2 is 10, x times x is x squared, and so that's what I would try and make my denominator. 5x squared in order to be a 10x squared multiplied by 2 on bottom. And then 10x in order to be 10x squared, I would multiply by an extra x on bottom and top. And then I would have common denominators, and I could add or subtract whatever that's. Now, when your rational expressions involve polynomials, like in the second example, I do actually need to factor, and you need to be comfortable with factoring mentally. So x plus 3 cannot be factored anymore. It's already linear. X squared minus 16 is the difference of squares, so this is 4 and x minus 4. Because the square root of 16 is plus and minus 4. Now in the other fraction, we have x plus 5, again linear, not factorable anymore. denominator, you need to use magic numbers. So if it takes a lot of writing for you to use magic numbers, I need you to start shifting to the mental way to find magic numbers, which is saying to yourself, what multiplies to give me 4 and adds to give me 5? Well, 4 and 1 do that. So my two factors are x plus 4 and x plus 1. Notice how I found my magic numbers in my head, and then I used them to write my factors. So I need to write the common factors of my denominator. Well, I notice that they both have an x plus 4. I notice that one of them has an x minus 4 and one of them has an x plus 1. So x minus 4, x plus 1. Well, if I multiply all of this together, then I'll end up with x plus 4 times x minus 4 times x plus 1. And that should be my common denominator. So in this ratio, I had the x plus 4 and the x minus 4, but not the x plus 1, so I would multiply bottom and top by x plus 1. Here, I had x plus 4 and x plus 1, but not the x minus 4, so I would multiply both bottom and top by x minus 4, and I'd have my common denominators. So I want you to pause your video and try to factor these two rational expressions, identify the common factors and the ones that are not common to each other, and then write them all together to make your least common denominator. So pause your video. So hopefully the add to give you 4, 2 and 2, 2, and then non-common factors of x plus 1 and x plus 2. So if you put them all together, x plus 2 and x plus 2 squared, and then you have the x plus 1. So this is just practice finding that least common denominator. To add and subtract rational expressions, factor each denominator if possible, just like we did in the previous examples. You want to find the least common denominator, and you should probably put out the side what that means. Once you find your least common, you want to multiply each rational expression, top and bottom, by whatever's missing so that you can have that common denominator on the bottom. And then add or subtract the tops, the numerators, by combining like terms. If you're subtracting, then all the signs in the numerator of the subtracted expression are going to change because you're going to have to distribute the subtraction sign. And then finally, factor and simplify if necessary. So, in problem number 1, I need to factor each denominator. So here, this is a 3 and an x. Here, this is a 3 times 2 and an x. So I notice that they both have 3's, they both have x's, but this one has a 2 and this one doesn't. So my least common denominator is going to be a 3 times a 2, which is a 6, and an x. It's all the pieces, the common pieces and the non-common pieces. Well, this denominator is already 6x, but this one is missing the 2, so we're going to multiply both numerator and denominator by 2. So 2 times 2 is 4, 3 times 2 is 6 with the x. This second fraction doesn't need to change because the denominator is already 6x. And now I add my numerators. So 4 plus 5 is 9 over 6x. And I notice that both 9 and 6 are divisible by 3, so I can finally simplify my answer. So 9 divided by 3 is 3, 6 divided by 3 is 2, and my final answer is 3 over 2x. So let's look at number 2. Number 2, 25. My pieces that are all the same. 5, y, and no other pieces are the same. So my least common is 5 and y. It has all the parts that they share and all. So in order for 5x squared y to be squared y squared, it's missing a 5. 5 times 5 would be 25. So we're going to multiply by 5 on top and bottom. It has the x squared, but it only has one y, and we need y squared. So we're going to multiply top and bottom by missing y. So 3 times 5y is 15y, and my denominator is 25 x squared y squared, just like I want it, minus, onto my second fraction. My second fraction, the denominator is 25, which is good. It has a y squared, which is good, but it's missing the x squared. So I'm going to multiply bottom and top by x squared, because it needs that x squared in the bottom. So 6x times x squared is 6x cubed. And then 25y squared times x squared is that common denominator, my least common denominator. And then finally, I want to combine my numerators. My denominators are the same now. So 15y minus 6x cubed over 25x squared y squared. And I don't see any common factors that I can cancel out, so this is my final answer. So at the beginning, it helps if you identify the least common denominator by circling the things that they have in common, and then maybe underlining the things that the denominators don't have in common. Okay, so number 3. There we go. Number 3, my denominators are already factored. There's nothing else that I can do to split these up. There's no other factors. So my least common denominator is going to have an x plus 2 and an x minus 2. There's nothing that I have that's the same. So I guess in keeping with the colors I've been using, I guess I should have done these in blue. But you get the idea that these are not the same. So the common denominators need to have one of each. This one has x plus 2 but no x minus 2. So I'm going to multiply by x minus 2. We'll have 3 times x minus 2 over x minus 2 times x plus 2. And then here we have x minus 2, but no x plus 2. So I'm going to multiply both top and bottom by x plus 2. Notice that the order on the bottom doesn't really matter, because if you multiply these two things together, it's the same as if you flip them. Think about those two factors being just whole numbers, like 7 times 10. 7 times 10 is the same thing as 10 times 7. It doesn't matter what order you write them in. But now you need to combine the numerators. So my denominator is still x minus 2 times x plus 2. But I notice that I can do some distribution here. So 3 times x is 3x. 3 times negative 2 is negative 6. Negative 8 times x is negative 8x. And I can combine some like terms here. 3x 8x is minus 5x. Negative 6 minus 16 is negative 22. All over x minus 2 times x plus 2. Now, the only thing that I can factor out of the numerator is a negative, and that's not really going to cancel out with anything on the bottom, so this is my final answer. Notice how the denominator is my least common denominator. Okay. Let's try number 4. So what I'd like for you to do, because number 4 is already factored, I'd like for you to write your least common denominator. And then after you write your least common denominator, I'd like for you to see if you can figure out what to multiply this fraction by on top and bottom, and this fraction by on top and bottom, so that your denominators can be the same. So find your least common denominator, and then try to multiply both fractions, whatever they need to be, to get those common denominators. So hopefully you were able to see that the least common denominator is made up of x minus 1 and 2x plus 1, so that should be your denominator. This denominator is missing the 2x plus 1, so you need to multiply both numerator and denominator by 2x plus 1. This denominator is missing the x minus 1 part, so you need to multiply both numerator and denominator by x minus 1. I have these two fractions, and so now it's time to start multiplying, or sorry, to start adding the tops. But I notice that both of the numerators have problems that really need to be foiled. We really need to have a polynomial up here instead of these factors. So what I'm going to do is I'm going to foil as I go. X times 2x, 2x squared, x times 1, 2 times 2x, 2 times 1, and then here plus x times x, x times negative 1, negative 1. To combine 2x squared x and 4x make 5x, minus 1x makes 4x, minus 3x makes 1x. Idea to check and see if you can factor the top by magic numbers. I need two numbers that multiply to be 15 and add to be 1. Well, there are no numbers that multiply to be 15 and add to be 1, because that would mean that they would be opposite signs 1 unit apart from each other, and that doesn't exist. So this is my first. Let's look at number 5. Number 5. Is already a linear factor, but this one can be split into the difference of two squares. So x plus 3 and x minus 3. I notice that there's an x minus 3 in both of these ratios. So x minus 3 will be in my least common denominator. However, x plus 3 will also be in there, because it's a factor that they don't have in common. So if my least common denominator is x minus 3 and x plus 3, well, this denominator already has both of those, so it doesn't need to be changed at all. This denominator only has the x minus 3, so I also need to multiply in the x plus 3 on the bottom and the top. So I will have x minus 7 times x plus 3 over x plus 3 times x minus 3. Now, whenever I combine the numerators, it will all be over the same denominator. I'll have 8x plus, I need to FOIL, x times x is x squared, x times 3 is 3x, negative 7 times x is negative 7x, and negative 7 times 3 is minus 21. If I combine my like terms, x squared is the only x squared term on the top. 8x plus 3x is 11x. Minus 7x, that's 4x. And then minus 21. All over the same denominator. Just like in the last problem, it's a good idea to see if you can do magic numbers with the polynomial on the top. So what multiplies to give you negative 21 but adds to give you 4? Well, the magic numbers that do that are a positive 7 and a negative 3. So I can break the numerator into the factors of x plus 7 and x minus 3. And what do you notice about the numerator and the denominator? They have a common factor which we learned yesterday when simplifying and dividing rational expressions, that you can cancel out common factors. So my final answer here is x plus good idea. Number 6 on your own. You're welcome to check back occasionally because I'm going to talk through the work, but I can show the work. And check back as you need to. Okay. So numbers 7, 8, and 9 are all going to require a little bit more factoring than normal. So I'd like for you to pause your video and try 7 and 8. Come back on and try to see if you got the right answer, and then you can try 9 as well. In number 7, the least common denominator has to have an x minus 2, but then also an x minus 3 and an x plus 2. So in the first fraction, you multiply by x plus 2. In the second, you multiply by x minus 3. You distribute your 2 and your 3. You combine your like terms and you get your answer. In number 8, when you factor these two denominators, you get x minus 1, x minus 1, and x plus 2, x minus 1. So x minus 1 gets put in the least common denominator, but so does this extra x minus 1 and the x plus 2. The first fraction needs to multiply by the x plus 2, and the second needs to multiply by the second x minus 1. You'll have to FOIL, but then you also have to distribute this negative, so the negative gets distributed here. You combine your like terms. I tried to factor out the 0, or negative, just to see if I could factor this trinomial, but I can't, so this is my final answer. And then on number 9, I know that you haven't done it yet, but we have 3 fractions. Only one of them can be factored, the denominators, into an x plus 2 and an x minus 2. That means that the least common denominator is x plus 2 times x minus 2. This fraction needs to be multiplied by the x minus 2. This one needs to be multiplied by the x plus 2. When you FOIL this and subtract 12 and add x plus 2, you get your numerator. I noticed that the numerator could be factored using magic numbers to get x minus 4 and x plus 2. These common factors cancel, and you're left with your answer.